Hello, we're going to start 2.5 today, which is solving by completing the square. Before we get started with that, I'd like you to do these two questions. They are not in your notes, so I'd like you to maybe get out another piece of scratch paper or something else to do these two questions. Notice that our first question we're going to be solving by taking the square root, so that's going to be coming from sections 2.1 and 2.4. And over here we're going to be solving by factoring. That comes from section 2.2 and 2.3. Just a little review of what we've done so far. So I encourage you to pause the video and try this on your own. So for this first one, I'm going to solve by isolating the x squared. Since I'm solving by taking the square root, I want to get everything all by itself. The x squared, that is, all by itself. So I get x squared equals -5. I then take the square root of both sides, and I get positive and negative I square root of 5, because I want to take out that square root of -1 from the radical. All right, let's go over to the next one. We're going to solve this one by factoring. Notice I do not have a 1x squared. I have a 2x squared. So I'm going to multiply my a and my c, and I get -24 up top and then a 5. So I'm looking for two numbers that multiply to give me a -24 and add to give me a 5. 8 and -3. So I come back up here and I'm going to rewrite my middle term using plus 8x minus 3x. Then I'm going to group my first two terms together and factor out my GCF. And then same thing in the back. I have to make sure that these match. So x plus 4 is one of my factors, and 2x minus 3 is my other factor. I then set each factor equal to 0, and I get x equals -4. And x equals 3/2. So those are my two solutions when I solve those by factoring. Right, so let's go ahead and get started with 2.5. We're going to solve quadratic equations, the exact same thing. We're just going to learn another different approach to solving quadratic equations. This one is called completing the square. As a warm-up, let's identify the number of real solutions. Now remember, when it comes to solutions, they're sometimes called roots, they're sometimes called zeros, but ultimately they are just x-intercepts. So I'm just counting how many x-intercepts does each parabola have. This one has 1, this has 0, and this one has 2. 1 and 2. So before we get to the process of completing the square, we're going to slowly work our way there. The first thing is I just have some introductory practice here. And if you see the x plus 3 quantity squared, remember that means this, which means in order to expand this out, I have to FOIL. So go ahead and pause the video and try FOILing all of these out. I'm now going to fill out this information in the table below. So I'm going to write the perfect square binomial, which is kind of the question that we started with, and then what it looks like expanded out. So I'm just going to fill in that information from above into this table. What I'm doing is I'm hoping that we see a pattern. All right, so what I'm trying to figure out is that if I only know B, let's say for instance that I do not know these values here. Say I just have the first setup. I just have x squared plus 6x, or I just have x squared minus 8x, or I just have x squared plus 4x. Can I use the value from B, which is this is our b value here, the number in front of the x, and our last number here is the c value. Can I use the value for b to get the value of c? I'm trying to figure out if there's some kind of formula that I can use to take our b value, which in this case is 6, and get out positive 9. Or can I take negative 8 and get out positive 16? It has to work for every single equation. Have you figured it out yet? Well, in order to get c, you're going to take half of b and square it. So I figure out what b is, I take half of it, and then I square it. The reason why that is important is hopefully what you'll see as we go through this. So for instance, on these questions here, I do not have my c values, but I do have my b values. So can we kind of go the other way? Can we figure out our c value and then from our c value write it as a square of a binomial? So what I'm going to do here is I'm going to take half of my b value and square it. So that means I'm going to take half of 10 and square it. Well, half of 10 is 5, and 5 squared is 25. So I add 25. Now when I do that, I now have this perfect square trinomial. To write it as the square of a binomial, which means it just has two terms, I just take half of my b value. So the quantity x plus 5 squared is the same thing as x squared plus 10x plus 25. Let's do it with our next one. I'm going to take half of negative 4 and square it. Well, half of negative 4 is negative 2, and negative 2, the quantity squared, is positive 4. So x squared minus 4x plus 4 is the same thing. I'm going to take half of this b value as x minus 2, the quantity squared. Now our next one is a challenge one. It doesn't have a nice even number to work with. I'm going to take half of negative 9, which unfortunately is negative 9 halves, and square it, which means I'm going to multiply it by itself. Negative 9 halves times negative 9 halves is 81 over 4. And then I would write this as the quantity x minus 9 halves squared. That was a tricky one. So let's get into the process of solving by completing the square. It's going to follow this 6-step process. Sometimes you'll be able to skip, steps 1 and 2 depending on kind of the setup of your equation. You will always have to do 3, 4, 5, and 6 though. So I'm going to start with this first kind of baby equation. We could factor this equation. We could factor out the GCF and the reverse FOIL just like we did in 2.2. But for today, I'm going to use an example that we already know how to work with, and we are going to solve by completing the square. So I've got 2x squared plus 12x plus 10 equals 0. The first thing I need to do is divide everything by 2. And I get x squared plus 6x plus 5 equals 0. The next is I'm going to get all terms with variables on one side, and we're going to move the constant to the other. So I'm going to subtract 5 from both sides. And when I do that, you'll notice I'm going to leave a little bit of space. Right? I'm going to leave a little bit of space here. I'm now going to add a half of a b squared to both sides. So I'm going to take this value of 6, take half of it, which is 3, and 3 squared is 9. So I'm going to add 9. Now if I add 9 to one side, I have to add 9 to the other, or I would have broken the rules of algebra. Now this is kind of the process that we were practicing on the previous page. I'm now going to go from steps 3 to 4, which is kind of the reverse, right? I'm going to take this and rewrite it as a binomial squared. These two things are equivalent. One is all FOILed out and one is not all FOILed out. Negative 5 plus 9 is a positive 4. Now, in order to solve this, I'm going to square root both sides. So I get x plus 3 equals positive or negative, the square root of 4 is 2. Now last but not least, I'm going to subtract 3 from both sides. So I get x equals, now I've got to consider both my positive and negative, 2 minus 3, which is negative 1, or negative 2 minus 3, which is negative 5. So I get out that my two solutions are negative 1 and negative 5. Let's go ahead and practice completing the square a few more times. Well, I can skip steps 1 and 2 because I already have a 1 x squared, or in this case w, and my constant is already on the other side of the equation. So what I need to do is I need to figure out what is half of negative 12 and then square it. Well, half of negative 12 is negative 6, and negative 6 squared is 36. So I'm going to add 36 to both sides. I must add them to both sides. I now write this as a binomial squared, which means I take half of my b value to get there. And negative 52 plus 36, that's negative 16. I then take the square root of both sides, so I get out w minus 6 equals positive or negative. Let's simplify the square root of negative 16 for I. I then add 6 to both sides, and because I like to put the real part of the answer first, I put that up front. So I get 6 plus or minus 4i, and then the last thing that I want you to do is determine whether the solutions are real or non-real. Because I have an I in my answer, these solutions are non-real or imaginary, however you want to write that. All right, let's look at our next equation. I don't have a 1x squared. So what could I, instead of divide by, what could I multiply by to get rid of that 1/2 in front of the x squared? Well, I could multiply by 2. Now, if I multiply my first term by 2, I have to multiply every term. So I get x squared minus 4x minus 8. I then add 8 to both sides. Notice how I'm kind of keeping that space there. I then take half of negative 4, which is negative 2, and square it. Negative 2, the quantity squared, is positive 4. So I add 4 to both sides. I then rewrite this as a binomial squared. I then take the square root of both sides. Now let's simplify the square root of 12. It's the square root of 4 times the square root of 3. So I get 2 square root of 3. And then last but not least, I add that over. I like to put the 2 up front just so I make sure to know what is under the radical and what is not. And because I do not have any i's in my solution, these both represent real solutions. Let's try our next one. Oh, this is already kind of nicely set up with a 1x squared. I just have to move that 17 over. So I get x squared plus 8x equals negative 17. I take half of my b value and square it. So half of 8 is 4. 4 squared is 16. I add 16 to both sides. I then rewrite the left-hand side as a binomial squared by taking half of my b value, and I get out a negative 1 there. I take the square root of both sides. Now the square root of negative 1, that's just I. I get x equals negative 4 plus or minus I, and because I have an I in my solution, these represent non-real solutions. All right, for this last one, this is a bit more of a challenge. I'm going to move the 6x over. So I have, excuse me, sure. I have 3x squared minus 6x equals -1. Now I'm not ready to square my b because I have to divide everything by 3. Now I'm going to take half of my b value and square it. So half of -2 is -1, and -1 squared is just +1. So I add 1 to both sides. I then rewrite my left-hand side as x minus 1 squared, the quantity squared, equals -1/3 plus 1 is 2/3. I then take the square root of both sides, so I get x minus 1 equals positive or negative square root of 2 over square root of 3. I write it out that way because I'm not allowed to have a radical in the denominator, so this I'm going to have to multiply. So I get positive or negative square root of 6 over 3, and then I have to add 1. So I get that my final answer is 1 plus or minus the square root of 6 over 3. And since that does not have any i's in my answer, it represents 2 real solutions. So that sums up 2.5. You have a homework assignment with only 6 questions, and that last question is kind of like this one where you unfortunately don't end up with a nice answer. You'll have some fractions in your answers, but go ahead and give that homework a try.